Hi, this is Ezra McCollum for Magnitude in Direction 2, and Part A asks you to determine the angle based off of the supplied image, and from that image you can tell that it's a right triangle, or you can turn it into a right triangle with sides 3 and 4 of length 3 and 4, and then through the Pythagorean theorem you can find the hypotenuse to be 5, um, and then you can use the equation sine of theta of equals 4 over 5, and then turn that into inverse sine as of 4 over 5, and you get an angle of 53 degrees. And then part B asks you to make another vector g of length 3d, and it asks you what the angle would be, and it would be the same because it doesn't really matter what the length of the vector is, because it's at the same angle as the previous vector. And then part C, it asks what angle would result with vectors g and d being placed tail to tail. And this had a little bit of confusion to me, but I assumed it would be 180 because if you place them tail to tail, they would be going in opposite directions, and it would result in 180, or they have the same direction and it would result in 180 because it doesn't change. And then part D asks you to create vector h, which is negative 3d, and determine what angle it would be if you drew a line horizontal to it. And I determined that it would still be 53 degrees because it's the same angle, just rotated 180 degrees, so it's 53 degrees to horizontal. And then part E asks what angle would be made with h and d placed tail to tail, and I determined that it would also be 180 degrees.